Hi, this is a video on how to solve question 5 from the AP Calculus AB 2011 exam. But let's be quite real here. When we usually look at questions like these, we end up looking like this monkey over here, falling asleep with our calculator in our hands and our notebooks, wishing by some miracle we are able to understand them. Last time I checked, this is an Indiana Jones movie, and I don't think Indiana Jones will make Indiana Jones and the calculus problem anytime soon. But like my calculus teacher always says, these are the enemies. So let's begin. At the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation shown for the next 20 years. W is measured in tons and T is measured in years from the start of 2010. For part A, they want us to use the tangent line to the graph of W at T equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010, and time T is equivalent to 1/4. Next, it tells us in part B to find the second derivative in terms of W and use this second derivative to determine whether the answer in part A is an underestimate or an overestimate of the amount of solid waste that the landfill contains at time T equals 1/4. And in part C, we must find the particular solution of W, which is equivalent to W of T, to the differential equation as shown with the initial condition W of 0 equals 1,400. Let's begin, shall we? So in part A, what are we actually looking for? Well, the line tangent to the graph of W at T equals 0 at the end of the first 3 months of 2010, as T is denoted by 1/4. Now, for the tangent line represents the instantaneous rate of change of the function, and the slope of the tangent line at a point on the function is equivalent to the derivative of the function at the same point. And here are our givens. In 2010, the landfill contained 1,400 tons of solid waste. Now, this is denoted by T equals 0, so we're going to have this point 0 and 1,400, because at time 0, we have 1,400 tons of solid waste to start. Our second little given is that we have the derivative of the function of W, and then this derivative shows the rate the landfill fills up. Now, we have to evaluate the derivative at T equals 0. So we plug in T equals 0 into the function. And since our given was that point of 0 and 1,400, we are able just to plug in 1,400 here. So resulting in 44. Now 44 is the slope of the tangent line. And then the tangent line is y equals 1,400 plus 44t, or y equals 44t plus 1,400. Now we just use simple y equals mx plus b format to find the tangent line. And since in part A, they also wanted us to evaluate it at 1/4, which is 3 months of the year, we have to use this equation to find the solid waste at time T equals 1/4. So simply just plug in 1/4 into the equation and you end up getting 1,411 tons. Now on to part B. So what are we looking for in part B? Well, we are looking for the second derivative, and if the answer in part A is an underestimation or an overestimation. So we will use the second derivative, which provides concavity, which determines if it's an overestimation or an underestimation. Something that's very important. If the tangent line between the point of the tangency and the approximated point is below the curve, as in the curve is concave up, the approximation is an underestimate, smaller than the actual value. If above the curve, as in the curve is concave down, then it's an overestimation. Now, half the time when we find explanations like this, we are literally saying this is confusing. But bear with me and we'll understand it better. So, we took the second derivative. Now, the idea behind this is since we have the derivative already here, what we must do is take the derivative of this, which ends up being 1/25th, and multiplying it by this function itself, because this function itself is simply, when you take the derivative, it is the second derivative, and you're only just going to multiply by 1/25, which is why you get 1/25 times the function, which ends up becoming this. Since W is increasing on the interval for the interval of 0 which is less than or equal to t, which is less than or equal to 20, and w of 0 equals 1400, which was a given, then the second derivative is positive and w is concave up. Therefore, the answer in part A is an underestimation of the solid waste in the landfill at time t equals 1/4. Now for part C. What are we looking for? Well, the particular solution of W, which is equivalent to Wt, to the differential equation. Wt is equivalent to the function as follows, with the initial condition W of 0 equals 1400. Now for this one, we have to understand the separation of variables. It's a method of solving ordinary and partial differential equations in which algebra allows one to rewrite equations so that two variables occur on a different side of the equation. And as we see here, we do that simply by matching W with dW, and since this doesn't have anything, we match it with dt. We have to take the integral here because the equation given is a derivative function and must integrate to get W function because we want to look at the W function. That's what we're trying to solve for. So by taking the integral, what we do is we are able to solve for W. Now, based on this integral with simple integral rules, we understand that 1 over x integrating that will be the ln. So we get the ln on this side, whereas this, because it's dt, and the integral of dt or dx will end up being that variable. So for dt, it's t, and for like dx, it will be x. Always remember, with indefinite integrals, you have to add the constant c. So, as in Mr. DePerry's class, always speak Spanish. Please remember initial conditions. So plug in 0 for t and plug in 1400 for w. Plugging that in, we are able to find and solve for the constant c. And all we're going to do now is just solve for w. And I skipped a step, but originally this was supposed to be w minus 300, which is equivalent to e to the t over 25 plus ln of 1100. And since we raised this, we're trying to free the ln structure, which is why we have it freed here, but 1 over 25t is raised in. You end up solving and finding w of t is equivalent to 300 plus 1100 e to the 1 over 25t, only on this interval, though. And we are finished. Thanks for watching.